This UMC-750 is connected to air and power and is operational. However, the machine must be leveled and checked for proper geometric alignment before it will provide optimal performance and accuracy. We will rough level the machine side to side and front to back. Then we will check for roll along X-axis travel. Finally, we will perform geometric checks and adjustments to assure all machine axes are correctly aligned. Measure from the base casting lower flange and lift the casting 4 inches off the ground by adjusting the 4 corner leveling screws to the same height. This provides a uniform position to start leveling. Take out the coolant pump to access the middle leveling screw on this side. Rotate both middle screws up to bring them completely off the middle pads. Attach leveling tool T2192 to the spindle housing with a precision level parallel to the X-axis. Visually verify that the edge of the level lines up with the T-slots. First, we'll level the machine side to side. Choose the side of the machine you want to adjust and lift or lower that side with even adjustments of the 2 screws on that side until the bubble is centered. Rotate the leveling tool so the precision level is now lying parallel to the Y-axis. We will now adjust the level front to back. Once again, check that the level tool edge lines up visually with a T-slot edge. Adjust either the front or back screws evenly to bring the bubble to the center of the vial. Now we will check roll along the X-axis. Leave the leveling tool parallel to Y-axis and move to one end of X-axis travel with Y-axis in the middle of travel. Jog X-axis from end to end, stopping in the middle to check X-axis roll. As you reach the end of X-axis travel, note whether the front or back side of the machine is lower on that end. Raise the lower side until the bubble reads 0. Repeat this step at each end of travel until the leveling tool reads 0 at both ends. Now we are ready to check B-axis to Y-axis parallelism. The middle screws will be seated in this next step and will be used to align the B and Y axes. After leveling the machine, our first alignment task is to check that the B-axis is parallel to the Y-axis up and down in the YZ plane and side to side in the XY plane. We will use the middle leveling screws to raise the middle of the machine to bring the B and Y axes parallel. After an additional reading, we will tilt the front trunnion support to the left or right, using the front leveling screws rotating opposite each other to align the B and Y axes side to side. When the machine is built, the table is made parallel to the B axis. Therefore, we can use the table surface to set B axis parallel to Y axis. 0 return the B and C axes. Mount your indicator on the spindle and bring Z axis down to indicate the table face. Jog X-axis to sweep the table over a distance of 20 inches. The reading should be 0 at both ends of the 20-inch sweep. If not, handle jog the B-axis to adjust the table position until the indicator reads 0 at both ends. Since our indicator reading is 1/1000th over 20 inches, we will adjust the B-axis to bring it to 0. Now, note the B-axis position. In our case, it is B0.003. Handle jogging B-axis parallel to the X-axis will serve us temporarily until the B to Y parallelism has been achieved. Later, we will check and adjust the B-axis home position. Raise the Z-axis up and command the C-axis to C90. Now we will check the parallelism of the table surface to Y-axis in the up and down direction. Starting at the back of the table, zero your indicator on the table face. Sweep with Y-axis from the back to the front over 20 inches. Record the indicator reading you find at the front edge of the table, noting both magnitude and direction. This measurement will show us the position of the table relative to the Y-axis in the up and down direction. We will adjust the B-axis by raising the middle of the machine using the middle screws. We see a reading of 0.02 with the table face moving upward in the positive direction away from Y-axis travel. As is always the case, the middle of the machine needs to be raised, so we will adjust the middle leveling screws using even increments on each side. With our adjustment made, we sweep back to front again, with the indicator set to 0 at the back edge and noting our reading at the front edge. Continue to adjust the middle screws up or down as necessary until the indicator reads 0 at each end of the 20-inch sweep. Now we will check the parallelism of the table surface to Y-axis in the side-to-side direction. Raise the Z-axis out of the way and recall that, in our case, we adjusted the B-axis position to B0.003. Now we will rotate to B 90.003 degrees. Move the axes to bring the indicator once again to the back edge of the table. Zero the indicator on the table face and sweep forward, jogging Y-axis from back to front over 20 inches. Record the indicator reading, noting both magnitude and direction. This measurement will show us the position of the table relative to the Y-axis in the side-to-side direction. In this case, the indicator shows the table face is angled 1/1000th to the right, away from the Y-axis, meaning the trunnion support is also leaning to the right. We will raise the right-hand side of the machine and lower the left-hand side using even amounts for each adjustment and adjust until the indicator reads 0 at each end. Sweep the table again to ensure it is aligned to read 0 at both ends of the 20-inch sweep. The B-axis has been aligned to both the YZ and XY planes. But the B-axis and C-axis home positions still need to be verified. The B-axis home position locates the table face parallel to the XY plane, and the C-axis home position locates the table T-slots parallel to the X-axis. Starting with C-axis home, 0 return the C-axis and bring your indicator against one of the T-slot walls. Sweep over a distance of 20 inches along the T-slot wall. With 0 set at the starting point, take a reading at the end of the 20-inch sweep. If the reading is 1/1000th or less, the measurement is within specification. Next, move your indicator out of the way and 0 return the B-axis, and bring Z-axis back down to indicate the surface. Again, set 0 at one end and take your first reading at the end of the 20-inch sweep. The specification for the B-axis home position is 0.02 over 20 inches. If either the B-axis or C-axis home position readings exceed their limit, then the machine leveling process will need to be repeated. Small errors in the leveling sequence can negatively influence the B and C home positions. In the unlikely event that you verified the level is correct, but the B or C home positions are still out of spec, a slight adjustment up or down can be made to the left or right front screws to change the B and C home positions a small amount. Recheck both home positions once you've made any adjustments. The spindle sweep measurement will show that the spindle axis is perpendicular to the table surface. Move the spindle head down to the middle of Z-axis travel. Attach the magnetic base to the spindle nose. Position the test indicator to measure a 10-inch diameter circle at the center of the table. Jog the Z-axis to bring the test indicator down to contact the table and zero the test indicator at the operator side of the table. Take a measurement every 90 degrees of rotation. This provides two values along the Y-axis and two along the X-axis. Total indicator reading for all four positions should not exceed 5/10,000ths. On a number line, our total indicator reading is 3/10,000ths TIR, which puts our spindle sweep measurement in spec. The spindle sweep values are also affected by the precision of the leveling sequence. If the values exceed specification, recheck the machine level. Parameters 1306 and 1307 tell the machine where the center of rotation of the table is compared to the X and Y axes. Parameter 1308 tells the machine where the B axis of rotation lies compared to the Z home position. You can use the WIPS probing system along with Visual Quick Code to check these parameters, which can then be reset if necessary. Before starting this procedure, ensure the probing system on the machine has been calibrated. The calibration process is covered on the Haas service site. Place the work probe in the spindle. Zero return all axes. Press MDI, Program, and Enter to select the VQC tab. Arrow down to the heading MRZP Set and press Enter. Select Finish MRZP Set. Place a tooling ball mounted to a magnetic base near the outside edge of the table. Locate the base so the ball arm is at a 45-degree angle to the T-slots. This ensures the probe tip won't contact the ball arm during the probing sequence. Handle jog the probe tip to a position 1/10 of an inch above and centered over the tooling ball. Input the ball diameter, which in our case is 1 inch, and press Enter. Choose Output to MDI and press Enter. Press MDI and cycle start. The probe will check the tooling ball at C-axis position of 0, 90, 180, and 270 degrees of rotation. Then it will check at B-axis -30 and -15 degree positions, and B-axis +15 and +30 degree positions. When the program is complete, it will place values in macro variables 106, 107, and 108. Press Current Commands and press Page Up repeatedly until you reach the macro variables screen. Press the right arrow several times to get to variable 106. Carefully record the values displayed for macro variables 106 through 108. Change the existing parameter 1306, 1307, and 1308 numbers to these new values. Macro variable 106 corresponds to parameter 1306. Variable 107 corresponds to parameter 1307, and variable 108 corresponds to parameter 1308. Be very careful to enter the correct value for each parameter. Double-check that you have recorded the correct values and entered these same values in the parameter fields. Even small errors during entry can result in large positioning errors. If for any reason you think the numbers were entered incorrectly, run the Finish MRZP Set program again. Your resulting macro variable values should be within 5 counts of the parameter numbers. With the Finish MRZP Set program run and parameters 1306 through 1308 checked and set as necessary, the rotary 0-point offsets have now been properly set and the machine is ready to run.